So remember, our coordinate plane is divided into 4 quadrants. This would be quadrant 1, and this would be quadrant 2. It goes counterclockwise, quadrant 3, and this would be quadrant 4. So which quadrant is point F in? Looks like it's in quadrant 4 because point F is right here. Quadrant 4 is going to be your positive x's and your negative y's. What ordered pair corresponds to the point labeled A? A is right here, so it looks like on our x-axis we move 1 spot and then we rise 2 spots. So it's going to be D, 1, 2 would be the ordered pair that corresponds to the point labeled A. Which points have positive y coordinates? Well, the y-axis is right here, okay? And if you look at the y-axis, the origin is here. Anything above the origin on the y-axis is going to be positive. Anything below the origin on the y-axis is going to be negative. So the positive y's are going to be all in quadrants 1 and quadrants 2, okay? And if we look at that, the only 2 points that both have positive y's would be A and B. If we're getting from these solutions here, right? So from these solutions here, the only 2 points that have positive y coordinates would be A and B. So next, state the domain and range, and then we have to say if it's a function or not. So domain would be all your x values, and I'm going to do this from least to greatest. So my first x value would be -3. Then we have, it looks like 0. 1 repeats, but I'm only going to write it once. And then we have 5, and those would be all my domain values. Range, going to do this from least to greatest. So it looks like the smallest one would be -4, followed by -2, then -1, then 1, and then 3. Okay, and this should have been a -1. So this is a function. Let's see, it looks like the 1's repeated, right? And that's my x. So if your x is repeated, it's not a function. So this is not a function. Create a mapping with this information. So remember, with maps, you want to go from least to greatest on both your domain and your range. You don't want to repeat any values. So we have -3, 0, 1, and 5. Over here we have -4, -2, -1, 1, and 3. And then just match your ordered pairs. So -3 was with 3. Make sure you match your ordered pairs. 1 was with 1. Then we have 0, -2, 1, 4. 1, I'm sorry, 1, -4, and 5, -1. And that's it. Next, for number 6, state the domain and range and determine whether it's a function. So if you're given a discrete graph, just write down the ordered pairs. Remember, your domain is going to be your x values, your range is going to be your y values. So this point right here would be 1, 1. This point right here would be 2, 3. This point right here would be -1, -2. And this point right here would be 4, -2. So what would my domain values be? If I'm starting from least to greatest, looks like it would first be -1, then 1, then 2, and then 4. What would my range values be? Well, if I'm starting from least to greatest, looks like it would be -2 first. Then we would have -2 again, but I'm not going to repeat. And then we would have 1, and then 3. Is this a function? Do any of the x's repeat? No, their x's do not repeat, and therefore it is a function. Yes, it is a function. Number 7, what are the domain values? We have 2 -3's. I'll just write down one of them. Then we have 0 and 4. And then for my range, we have -5, 0, 1, and 7. Is this a function? Your x's repeat, right? So no, it is not a function. And then number 8, what is my domain? It looks like we have 3, 6, 12, and 18. Remember, your domain values on your map are your first column, and it was also labeled x, your first oval. What would your range be? Your range would be 5, 7, 9, and 10. Is this a function? Well, right here I have 2 6's. The 6's repeat. Therefore, no, it is not a function. So is this a function? Actually, before we figure out whether it's a function or not, let's figure out the domain. So if we scan from left to right, it looks like at all points I'm touching this parabola. At all points I'm touching something on this graph. So therefore the domain is going to be all real numbers. What would my range be? For my range, I'm going to go from bottom to top here. So it looks like I'm touching points all the way until I reach this right here. And where would this be on the y-axis? It looks like it would be a positive 3. So what's happening at positive 3? My graph, my parabola is going downwards. So that's going to mean that y is going to be anything that's below 3, right? And I hope you could see that with the line. Y is anything below 3. So it would be y is less than or equal to 3. Is this a function? Well, if we do the vertical line test, I would need this one again. If we do the vertical line test, is there ever a spot here? Let me move this one out of the way. Is there ever a spot where I'm touching more than 1 point? No, there isn't. Therefore, it passes the vertical line test, so yes, this is a function. So here, for domain, if I scan from left to right, I'm touching points, I'm touching points, I'm touching points until I reach this x value here. Where would this be on the x-axis? That's positive 1 on the x-axis. Now, what's going on positive 1? Okay, is the graph, and we're talking about the x here, right? So we're only looking at the x, we're not looking at the y. So at positive 1, is the graph going towards positive infinity, which would mean greater than or equal to, or at positive 1 is the graph going towards negative infinity? Looks like it's going towards negative infinity. So that would mean that the inequality for this domain is going to be x is less than or equal to 1. What would my range be? Well, if we, I'll just leave this over here. If we get this line here and we scan from bottom to top, there's not a point. I'm always touching something on the line here, right? There's never a point where I'm not touching something on this graph. So therefore, the solution for range would be all real numbers. Is this a function? Well, I'd need this line again, and I'd need to do the vertical line test. So if I do the vertical line test right there, I'm touching more than 1 point. Right? Can you see that? I'm touching more than 1 point right here. That's 2 points there. So therefore, this is not a function. So is this a function? No. So here we're given an equation and we're asked to create a function table and then graph its values. So when we're creating a function table and graphing its values, we're just plugging in the x value into our original equation, which was x minus 3. So if we plug in -1, it would be -1 minus 3, which equals -4. So that first y value should be -4. If we plug in 1, it would be 1 minus 3, which would be -2. So that second value would be -2. If we plug in 3, it would be 3 minus 3, which would be 0. So that third value would be 0. And if we plug in 5, it would be 5 minus 3, which would be 2. So that fourth value would be 2. So now let's go ahead and graph it. It would be -1, -4, which would be right here. That's your first order pair. 1, -2, which would be right here. 3, 0, which would be right here. And then we have 5, 2, which would be right here. And that would be your graph. Again, same thing. We're going to plug in -2 anywhere we see an x. Remember, whenever you have a number or a fraction right next to a variable, it means multiplication. So if we plug in -2, it would be 3 minus 1/2 times -2. And -1/2 times -2 is +1, and 3 plus 1 would be 4. Now if we plug in 0, it would be 3 minus 1/2 times 0. 1/2 times 0 is 0. 3 minus 0 is 3. If we plug in 2, it would be 3 minus 1/2 times 2. -1/2 times 2 would be -1. 3 minus 1 is 2. And last, if we plug in 4, it'd be 3 minus 1/2 times 4. Negative 1/2 times 4 is negative 2, and 3 minus 2 is 1. So if we go ahead and plot this, it'd be negative 2, 4, which is right here. Then we'd have 0, 3, which is right here. 2, 2, which is right here. And 4, 1, which is right here. And that would be your graph. So 13, what I would do is I would just start plugging away. So if I plug in 2 into this first equation, it would be 1/2 times 2 minus 5. Well, 1/2 times 2 is 1, and 1 minus 5 equals negative 4. So this actually works out quite well, because that's what I have here, and therefore this is probably going to be A. All right, that's going to be A. A is going to be 13, because it worked out. It's not always going to be that easy, so let's take a look at 14. So 14, if I plug in 3 for 14 here, let's see if I get negative 1. So that would be 4 times 3 plus 3. Well, 4 times 3 equals 12, and 12 plus 3 is 15. So that's obviously not negative 1. That's not going to work out. So if I plug in 3 for 15, let's see what I get. It would be negative 2/3 times 3, which would be negative 2, plus 1. And negative 2 plus 1 is negative 1. So it looks like 15 is going to be the one that's B. So let's try 1 over here in number 14. It would be y equals 4 times 1 plus 3. 4 times 1 is 4, and 4 plus 3 is 7. So that's going to be C. And then obviously 16 would be D. That's it. It's your study guide video. Tomorrow's test will also have some stuff about dependent and independent variables, so make sure you review some of those notes. And we'll also have some stuff in function notation where you'll have to find f of 1, f of 2, and all that, which you've been doing all week in Delta Math. So be prepared for tomorrow's test. I will see you tomorrow.